Hi, this is video 2 about expressions and equations. Today we're going to be talking about equivalent expressions. Equivalent expressions are expressions that are going to have the same value. When we look at two expressions, they might look pretty different. They're going to have different numbers in them. They might have different coefficients, different amounts of terms. These two expressions are equivalent. So 12h and 5h plus 7h, those are equivalent. So maybe you can think for a second about why. And these are going to be equivalent expressions because no matter what the value of h, they're going to have the same result. So if h is equal to 2, both of these expressions are 24. The 12h, that would be 2 times 12, so that's 24. And then here we do 5 times 2 is 10, and 7 times 2 is 14. So again, we would have 24 if we add those two together. So you can kind of see, we don't always check using a value, but we kind of know that these are going to be equivalent, which we'll see in a second, why 12h is equivalent to 5h plus 7h. There could be a lot of different expressions that are equivalent, so not just two that are equal like this one. There could be multiple. There's an infinite number of expressions that are equivalent, but also there's a lot of expressions that are not going to be equivalent. Clearly, 4h plus 9h here, this is not going to be equivalent because if you use 2 for the value of h, 2 times 4 is 8, 2 times 9 is 18. You add those two together, and you get 26, and we're trying to get 24, so that would not be an equivalent expression. So let's move on. So there's some properties, mathematical properties that we've already learned about. They're really fundamental, which we can use to find equivalent expressions. One of the properties that's very important is called the commutative property. If you look here, we are switching order of two terms. Okay, so 2x plus 3x, we're going to switch that, and that's going to become 3x plus 2x. So it's switching order. That's what the commutative property is. And it means basically we can reorder terms around in an expression to try to simplify it or write an equivalent expression. The associative property means we get to choose in which order to add. So here we have 2y plus the quantity 3y plus 4y. What's in the parentheses is what we should add first, following the order of operations. So we would add these two terms first, 3y plus 4y, which we'll see is going to give us 7y in a moment. So that would give us 7y. But here we can switch the order. We can choose to add the first two terms. Instead of the 3 plus 4, we could add the 2 plus 3, and that would give us 5y first. Now either way, we're going to have an equivalent expressions, because then if I add 2y plus 7y, I'll get 9y on the left, or on the right, 5y plus 4y again is 9y. But associative property is choosing what to add first, grouping. And very important, the distributive property. So when we have a number that is in front of a parentheses, like this 6 here, this is a multiplier. Any number in front of a parentheses. And we're going to use the distributive property a lot when we're finding equivalent expressions. So we're going to do 6 times 1. Sometimes I draw arrows like this. 6 times 1 is what? Well, 6. That's our first term. And then we distribute the 6 over here as well. We multiply it twice or even 3 times. 6 times 3 is 18. So 6 times 3k is 18k. And this distributive property allows us to expand. This is called expanding this expression on the left, removing the parentheses through multiplication. All right. Like terms, very important. In an expression, we want to combine them. This means to add 2 or more terms together that have the same variable. They got to have the same variable by adding their coefficients. So I kind of showed you that before, but we'll see it again. Constant terms can also be combined. So let's see an example of like terms. Here's a thing to do. So we have this expression negative 16x plus 5 plus 20x. We want to combine some like terms. There it is. We're looking at it and saying, what could I add up? I have some plus signs here, plus 5 and plus 20x. So I want to try to add something, clearly. First, we use the commutative property. So we're going to switch these two terms, the second and third terms. Why am I going to do that? Because now the two terms with x in them, which are called like terms, we can add those up. Your book shows it this way, which is to see that if we use the distributive property, we can reverse the multiplication. So it's kind of like here's x, and x had been multiplied by negative 16 to get negative 16x. X had been multiplied by 20 to get 20x. How I see it is really just, what's negative 16 of something, negative 16 times something, plus 20 times something? Well, it's 4, right? So 20 and negative 16 are going to give us 4. I'm showing this step just because this one is in the book. I don't typically do this step using the distributive property. I just add coefficients. So negative 16 plus 20 is 4. But you always want to look for like terms. So anytime you have two terms with x in them or a in them or a constant term, like if we had a 4 at the end, we would add 4 plus 5 is 9. We always want to add them up and simplify. So this is called simplifying as well. This had 3 terms to begin with, 3 terms. Now we're down to just 2 terms. I'll just write a t, 2 terms here. So that's simplifying because we're writing it with less information. And identifying equivalent expressions, there could be, again, as I mentioned in the first slide, a lot of expressions that are equivalent. So here we have Geraldine. She spent $80 already. She's going to make some cookies, and then she's going to sell them for $2 each. So what's an expression that could show how much she's raised after selling C cookies? So she's already spent some, and then she's making some money back. So we have some options here. 2c minus 80, 2 times c minus 40, and negative 80 plus 2c. So you might think about these expressions. Do any of them represent how much she's raised after selling C cookies? So, probably at least one of them is, and this expression is correct. Why is it correct? Well, she makes $2 per cookie, so that's the 2C. We talked about per before in lesson 1. And the minus 80 is she's already spent 80, right? So minus means bringing down in value or losing something. She's already lost $80 to get the supplies. So once you've identified one expression that's correct, 2c minus 80, you can compare that to the other two and think, well, would those be equivalent? So if you look at the second expression, think, well, is that one equivalent to the first expression? Are these two equivalent? Turns out this one is. So again, if we use the distributive property, 2 times c is 2c, 2 times 40 is 80, and there would be 2 times negative 40 is negative 80. So the sign is going to match as well, so minus. So using the distributive property, this is also an equivalent expression. And how about the third one? We got a negative 80 here. That seems good because there's a negative 80 there. And we got a 2c here, which seems good because there's a 2c there. So turns out this is also an equivalent expression. All of these expressions are correct for how much she's raised after selling C cookies. This expression is using the commutative property, which again is switching the order of the two terms. So these two terms got reversed. So not always would all of the expressions be correct, but in this case they all are equivalent because they're kind of demonstrating a couple of the properties that we use. then 2 or more steps. Sometimes we got to do a lot of work to find equivalent expressions. So you look at this expression, right? We got a lot going on. -3 times 2/9 of p minus 6. We got fractions adding 4/3 of p and then subtracting 13. So what can we do? Start with your expression. First, distributive property. So -3, when you look in the front, that is a multiplier. If you multiply -3 times 2/9, you're going to get -6/9 times p. If you multiply -3 times -6, you're going to get +18. You always want to do the distributive property first if you can. Commutative property, that means we're going to swap terms. So again, I'm going to choose to swap these 2 middle terms so I can get the p terms next to each other. This term has a p in it, this term has a p in it, and then the 2 constant terms next to each other, which are 18 and -13. So I get them next to each other so that I can then combine. And now if -2/3 plus 4/3 is 2/3 of p, and 18 minus 13 is 5. So we have kind of 2 sets here of like terms. We've got these 2 terms are like terms, and they're going to give us this. And then we have these 2 terms are like terms, and they're going to give us this. We can't combine any further because if you have something that's unknown, this is a variable term that's unknown, 2/3 of p, can't combine that with a constant term, which is 5. Those would not be combined. And finally, checking. So you can always check if expressions are equivalent by just choosing a value of the variable. So we kind of did this in class, and some of you had this as an idea to write some expressions. These are the 2 expressions that we just did in the last slide. This long one to begin with, and then the shorter one. So if you just say, well, I have this variable p, right? What if I choose p is 9? See what works out. So if I do the first one, if I do the easier one, 2/3 of 9, that's 6. Then 6 plus 5 is 11. Really easy to check if this expression is equal to 11. Other one's a little harder. You got to do some work. Looks like a lot of work, but when you work that out, you could just type it into a calculator as written, putting 9 in twice for the value of p, you're going to come out with 11. And if that happens, it's usually good to actually test 2 values. You would want to test another value of p, like p is 0, for example, and you get the same answer, then that's telling you that you're right, that you have 2 equivalent expressions. So thank you for watching today's video. Trying to make it a little shorter. Make sure you took the notes so you're ready to do lesson 4-2. I believe that starts on page 198 to 200. So good luck.